everyone. Welcome to Let's Unbound. Today, I'll be discussing 5 marker questions which came in Math Kangaroo 2024 for level 5 and 6. So let's get started. This is the first question, which is question 21. There are 3 identical special dice on the table. What is the sum of the numbers on the faces that touch the table? So as you can see, I have named all the 3 dice as PQR. And now we need to think about what could be the number at the bottom of the dice. So let's just start with dice P. As you can see, we need to find the value at the bottom. So what do you think? The value at the bottom should definitely be adjacent to 22 and 8 because that's all is visible to us, right? So that means it should be adjacent to both 8 and 22, right? So let's take help from the other 2 dice given to us. We see that 13 is adjacent to 8. Can you see that in the picture? Yes, 13 is adjacent. And also in dice R, you can see 13 is adjacent to 22 also. That means for both 8 and 22, we can see 13 is adjacent. So that means 13 should definitely be the bottom digit for the first dice. So that means 13 will be the answer for the first one. So let me write it here as well. Okay. Similarly, let's look for Q and R. So for Q, we have 2 digits visible, that is 8 and 13. With the help of the other 2 dice, can you see what will be adjacent to 8 and 13 both? So we see that 22 here and here, they are adjacent to both 8 and 13. That means definitely 22 should be at the bottom, right? So 22. And for the third one, we need to find a digit which is adjacent to both 13 and 22. So let's take help of the first 2 dice. So we can see 8 is adjacent to 22 and here 8 is adjacent to 13. So that means definitely this 8 should be at the bottom. And now why I'm taking help of all these other dice? Because they have said these are the 3 identical special dice on the table, right? So if they're identical, that means all the 3 dice are same. And we can take help from the other dice and get an idea that how they are related to one another. So all we have to do is just add them up. So what will be 13 plus 22 plus 8? Yes, that will be 43. So option C. So you can see it's such an easy question. All we have to focus is on what the question exactly delivers and how we need to look at the logic of the question. Okay, let's move to the next question, that is question 22. Question says the diagram shows 4 touching rectangles. What is the area of the shaded rectangle? So you can see here the 4 rectangles are mentioned. So let me give name to all the rectangles A, B, C. And the middle one is already shaded, so I need not give a name to it. We need to find the area of the shaded rectangle. Now we know whenever we need to find area, we need length and width both. But before reaching to this length and this width, we need to first see what other information we can collect from the question. Yeah, as you can see, the rectangle A gives you some information about area, and that is 45 centimeters square, right? Okay, so area is what? Length into width. So we have some information, that is L times 5 gives you 45 because you can see that your width is given to you as 5 centimeter. So we can easily find the length by calculating this, and you can see length will be 9 centimeter. So let me quickly name it as 9 centimeter here. Okay, let's have a look now for the rectangle B. Again, area is 40 centimeters square. And what is given to us this time? Can you have a look? We don't have width and we don't have length, but definitely we can find it because just now we calculated this is 9, right? Because the total is 13 and this is 9. So what will be your width? Can anybody tell me? Yes, of course, it will be 4 because all we have to do is 13 minus 9. All right, so now we can find the length as well by just dividing by 4, and that will give you 10 centimeters. So you can see how easy it was and we were able to get the answer till here. Next up, we have our next rectangle, that is C. And now we again need to find what we can get for rectangle C. So area is 48. And now what is the width? Can anybody tell me what will be this width? So easy. Total is 16. As you can see, total is 16. And we just calculated this much portion as 10. So 16 minus 10 gives you the width for rectangle C. So that will be how much? 6. Okay. So we get this much as 6. And here also let me write this was 4. Okay, so now can you find the length? Very easy. I've already shown it here. It is 8 centimeter. Okay. By just using the formula of area. Now, all we need to do is try to figure out what will be the length and width for the rectangle, which is the shaded rectangle. Okay. Now think about, let's say, this width. Okay. You can see we need to first find what will be this. Can I say this highlighted width is nothing but 8 centimeters, and how much was this? 4. So can I subtract 8 minus 4 and I will get this hidden piece? Yes, of course, right? So that means the width for this shaded rectangle is 8 minus 4, that is 4 cm. And now what about the length? That is this. How can you find this? What is this total length? 10 centimeters, because we calculated in the previous steps. From 10, we need to subtract this much. And how much is this much? Of course, it's 5. So 10 minus 5 gives you 5. So how easy it was. We got the length as 5 centimeters, which is 10 minus 5. So can you see we calculated length also and width also. Now all we have to do is just multiply, apply the formula of area of rectangle, that is length into width. And you see we get 4 times 5, which is 20. So area of the shaded rectangle will be length times width, which is 5 times 4 gives us 20. So option E. See how simple it was. We got our answer correct. Moving on to the next question. Question 23. The figure shows the plan of the 7 train routes of a small town. The circles indicate the stations. Martin wants to paint the lines in such a way that if two lines share a common station, then they are painted with different colors. What is the smallest number of colors that he can use? Now, if you have a look at the picture, it's such a confusing route. So they have said, let me just highlight and see what you can figure it out. I have highlighted this statement. Let's read it again. It says, if two lines share a common station, then they are painted with different colors. Why don't we think in a different way and say that what if they have no common station? Then it means we can use the same color, just the opposite of what they are saying, and we are still in the right direction. So let me have a look at the stations and see which two or three they don't share any stations, so that we can share the common color, because after all we need to find the smallest number of colors. Okay. Okay, so let me just have a look at the vertical stations. Can you have a look at 4, 5 and 6? Is there anything common between them? No. They're all vertical, separate station routes. Can you see? Nothing common between them. So that means, why don't I take same color for 4, 5, 6? And let me color it green. Okay. Now, let me have a look at another station. What about 1 and 3? Is there anything common between 1 and 3? No, 1 is here and 3 is here. That means I can take same color for these two because there's nothing common. So I'm taking up pink. And lastly, let me have a look at 2 and 7. See, if I talk about 2, there are so many stations in common with 5, 6, and there was one more station here and here. So that means definitely I cannot take for station 2 same color as green or pink. So I will have to definitely take a new color. So let me take blue color for my station 2. Now what is left? Station 7. Okay, can you see in station 7? Let me just highlight it for you. You can see there is nothing common between station 7 and station 2. So why don't I give the root of 7 also as same color blue? Okay, let me just show you. And we are done with the question. You can see that how easily we have given the minimum colors, and we have also maintained the condition of the question. And what I did was, they said we need to paint in such a way that if two lines share common station, they are painted with different colors. And I took it in another way. I said, what if there is nothing common? So I will take the same color. It made my task even easier. So what we did in the last step, we painted the roots 2 and 7 with blue color. So minimum how many colors I've used? 3 colors, green, pink and blue. So what should be the answer? Of course, option A. And yes, you can see that's the correct answer. Moving on to the next question. Question 24. It says, Domain wants to fold the net shown to make a cube. He wants the triangles that touch the edges of neighboring faces of the cube to be shaded the same. How should he shade the triangles of the unshaded square in the net? Now you can have a look that this one, last one, is the unshaded square, and we have to shade it in such a way that it should touch the edges of the neighboring faces of the cube. If you see, if I try to build a cube out of it, can you tell me that the four edges will touch which four boundaries from the rest of the sides of the cube? Okay, just have a look. Can you see this boundary? Of course. So this part should resemble exactly like the other. Okay. What about if I say this face? So once we form the cube, it should match exactly like this one. Similarly, when I shade this, it should match the opposite one. And when I say this, it should match this one. All right. So it should be in the same way as they are shaded. So let me give some marking. This side, I can call it as 1. Okay. Then this one, let me call it as 2. And I've marked here also 2 to make it quite easy. After that, sorry, this one will be 2. This one will be 3. and this one will be 4. Okay. So for the first one, of course, we need to paint this also exactly to make it look similar. Okay. So out of the 4 options, we can see the shaded part are all on this side. So it's hard to select. Now let's just check for the second. So if you look at the second, the boundaries here, so you can see one part is shaded and another is non-shaded. So what do you think? Shall I shade it like this? Should this be my picture? No, think again. When we try to fold this and make a cube, right? So what will happen? Where will it go? This side is going to touch this end and this side is going to touch this end, right? So that means it should be opposite so that when they're folded, this particular side where I've put a dot, it will match this side and the non-shaded one will match this side. Okay, so let's see. Do we have any option? Yes, A, B, and C, they all resemble like that. Okay, let me keep shading it so that it becomes easier for you. So we are done with the boundaries of 1 and 2. Let's have a look with the third one. What do you think? So when we match it, how it should look like? So you can see it is shaded on this side. So when we fold and we form the cube, it should exactly be like that, right? It should be shaded on this part. Okay, so I'll shade it for you. So third is also done, right? Now, fourth one. How the fourth one will look like again. As we did for second, it was just the opposite. Same way for fourth, it will be opposite. So if it is shaded on the right, here we need to shade on the left. So that was the whole trick. Now, whatever image we have got here, try to resemble from the options. Which option it resembles? That will be the correct answer. So we can see clearly it is option B. Okay. I hope this was easy. Moving on to the last question and the most simple question. Simon takes 4 cups out of the cupboard and puts them randomly on the 4 saucers. For each cup, there is exactly one matching saucer. Which statement is correct? First statement says, it is certain that none of the 4 cups stands on its matching saucer. Okay, you think this is right? No, because obviously, if even if you try to keep maybe this on some other saucer and this cup again on the mismatched saucer, that's fine. But we cannot say that none of the cups will be on its matching. Okay, so let's see B. It is certain that exactly 1 cup stands on its matching saucer. No, there are possibilities we can match 2, 3, and even 4. C. It is impossible for exactly 2 cups to stand on their matching saucers. This is again incorrect. Why is it impossible? We can put the same saucers with the same matching cups. D. It is impossible for exactly 3 cups to stand on their matching saucers. What do you think about this statement? It says it's impossible for exactly 3 cups to stand on their matching saucers. And this is correct. You know why? Because if 3 saucers are matched, for example, this cup matches to the last one because they are of the same pattern, the second one with the first, the third one with the third. Now, these are exactly 3 cups with the matching saucers. But what about the fourth one? Obviously, it will automatically go to the matching one, and we can never get exactly 3 cups because the moment you match the 3 cups, the fourth one will automatically be matched to the fourth saucer, right? So that means this statement is correct because it says it is impossible, right? It's never possible to match 3 cups and leave the fourth one. All right, so this was the most easy one. Without any calculation, we can do this question. So this was all for today's session, and I will meet you in the next class with more 5 marker questions from Math Kangaroo 2024. Until then, keep studying and stay motivated. I'll see you in the next video. Bye bye.